We're going to look at substitution again. We started looking at this yesterday, so we're going to practice a few more problems. So the first type of substitution is when you can set two equations equal. So let's do an example. Number one, Tim starts a new part-time job and he earns $135, which he saves and does not spend. All right, so I'm going to underline the important information. Erica has $250 saved up, and she also starts a new part-time job. She works fewer hours than Tim, so she earns $100 a week. And so I'm going to say that Tim also earns $135 a week. Okay, let's write two equations. Let's start with Tim. So for Tim, we're going to say y equals, and he earns $135 a week. And for Erica, she had some money saved, $250, and she also starts a new part-time job. So she earns $100 per week. So the rate of change, the slope, we put next to x, and x is the number of weeks. For Erica, she has a y-intercept. It's 250. She starts with that. And Tim, his y-intercept is 0 because he starts with a 0. So when you have two equations that are both y equals, and you want to figure out when they earn the same amount, you set them equal. Okay, and this is actually substitution. What we're doing is, since they both equal y, we can plug this in for y and solve. So that's what we're going to do. So set equations equal and solve for x. So we have Tim's equation, the 135x, equals Erica's equation, which was the $250 plus her $100 per week. Let me double check here. Yep, okay, so next step, set them equal. Now we solve. Let's get x on one side. Let's get rid of this $100 x from the side. We'll get 35x equals 250. We'll divide each side by 35. And so we'll get x equals about 7.14 weeks. So at 7 weeks, they earn about the same amount. It says plug in your answer for x and solve for y. So at 7.14 weeks, they have about the same amount. Let's see what that amount is. So to do that, pick one of your equations, either equation. I'm going to choose Tim's because it's a little bit shorter, and we're going to plug in. So we have y equals 135x, and I'm going to plug in the 714 for x. So we have 135 times about 714. And at 7.14 weeks, they have about the same amount at $964.29. So this is called solving a system. You have two equations, and basically it's where do the two lines cross, where are they tied, and it's a location, a point, and you want to find the x and y value where they cross. So that's one way to do substitution, setting the equations equal. And again, what do the answers mean in this problem? It means at 7 weeks they have about the same amount of money, which is about $964. So there's another type of substitution, and that is when either x or y is by itself. So if you take a look at number 2, y is by itself. Both y's are not by itself, but one y is by itself, and so we're going to use substitution. Since y equals 9 minus 2x, we're going to plug that in for this y here. We're going to completely replace y with 9 minus 2x. So here's what it looks like, 3. And then we'll substitute in 9 minus 2x, and then write the rest of our equation. So we have minus 2x equals 11. Now we have one equation with one variable, and we can solve. So let's distribute. We'll get 27 minus 6x minus 2x equals 11. Let's combine like terms. The x's on one side, we can put those together. So we'll get 27 minus 8x equals 11. Let's subtract 27 from each side. We get negative 8x equals negative 16. We'll divide each side by negative 8. So here x equals 2. So these equations cross, and they cross when x is 2. They intersect. But we need the y value. To find where the two lines cross, we need the points. We need x and y. So plug into your equation where y is by itself. And so we have y equals 9 minus 2 times x, and we know x is 2. So plug that in, and we're going to solve. So we have y equals 9 minus 4, so y equals 5. So these two lines, they cross at the point 2, 5. And you could plug this in for x and y into the first equation to check your answer. So let's do that. 3 times y is 5, minus 2 times x, 2 times 2. It should equal 11 if we did this right. So we have 15 minus 4. Does that equal 11? And it does. So you can check your answer by plugging in and making sure both sides are equal. All right, let's take a look at one more example. This time x is by itself. Okay, so let's take what x equals, this 2y minus 3. We're going to plug that in for x. So let's rewrite the equation. 3, and instead of x, replace that with 2y minus 3 minus 7y equals negative 14. Let's distribute. We'll get 6y minus 9 minus 7y equals negative 14. Let's combine like terms and solve. So we have 6y minus 7y, that's negative 1y, minus 9 equals negative 14. Let's add 9 to each side. We get negative 1y equals negative 5. Let's divide each side by negative 1. So we have the y value, y equals 5. But again, we want to know where these two lines cross. We need the x value. So plug into your equation where x is already by itself. X equals 2 times y, but y is 5, so let's plug that in. Minus 3, and solve for x. So x equals 10 minus 3, so x equals 7. So these two points cross at 7, 5. These two lines cross at 7, 5. And you can check your answer by plugging in 3 times x, which is 7, minus 7 times 5. Does that equal negative 14? So we're checking this, and we have 21 minus 35. And that does equal negative 14. So again, you can check your answer. So we have two lines, they cross, and they intersect at 7, 5. So for your assignment today, you're going to practice these three types of problems. Write your equation, y equals, set them equal, and solve, or plug one in for the other and solve.